Hello everyone, myself Yashoda. Here I am discussing the chapter Oscillators, which is comes BSc 6th semester in the 6.1 paper. So let us discuss about introduction about the oscillator. So oscillator is an electron circuit that generates an alternating voltage. So this means the circuit converts DC voltage into AC voltage of desired frequency. That's why it is also called as the energy converter, and it does not require any external input signals. So it does not require any external input signals, but also it converts by dc power supply to the dc power supply to an AC voltage. So in the oscillatory circuit, an amplifier is used to magnify weak input signals. So in the oscillatory circuit, you have the amplifier and the feedback network. So these are the two most important and essential networks to works an oscillator. So to understand oscillators, the concept of feedback network is essential. So feedback network plays an important role in the oscillator. Concept of feedback. So feedback process in is one in which a fraction of output signal of the amplifier is fed back to the input of the amplifier. So here is the let us consider the input signal and the amplifier. So when it gives the input signal to the amplifier, it gives the output, and that output signal is acts as input signal to the amplifier again through feedback network. So that's why the output signal of the amplifier is fed back through the feedback network to into the as input of the amplifier. The feedback signal can be either a voltage or current. At input, there are two signals, one from input source and another from output of the amplifier. So why here output of the amplifier? Because the output signal of the amplifier is again fed back through the feedback network into an input signal. So that's why at the input there are two signals. The one is from the input itself, source itself as a input signals, and the again one is comes from the feedback network. A feedback amplifier can be understood from the figure clearly. So here let us consider the Vs is the source signals, and Vi is the input voltage, and amplifier with gain A. So you know that the amplifier gain is called as, it is the ratio of output by input. So and here is the output and feedback circuit, that is beta, and Vf is the feedback voltage, that is equals to beta into V naught, where beta is the feedback fraction, V naught is the output of the amplifier, and Vf becomes the feedback voltage. Here when the source gives the input signal to the amplifier, and amplifier is used to here the magnifies the weak input signals. After that it gives the output. That output V naught is fed back through the feedback network, gives us the gives out of the voltage. That voltage will gives to the input signal as from the feedback circuit. So that voltage is called as the feedback voltage, that is denoted as Vf, that is equals to beta into V naught. So let us consider the AV be the voltage gain of the amplifier. It is, you know that the voltage gain, we can write here the ratio of output voltage to the input voltage. Output voltage is the V naught, and input voltage is Vi, and its input voltage is Vi and output voltage is V naught, then the gain can be written of the circuit is given by the AV is equals to V naught by Vi. Well, I am here wrote Vi plus Vf because here in the feedback by the feedback network, the output signal is fed back through the feedback network and it add up with the input signal of the amplifier. Input signal of the source, that input signal is Vi and plus Vf is the feedback voltage. So in the input you have the two signals, one is from the input of the source and another one is feedback voltage from the feedback network. So where Vf is equals to beta into V naught, where beta is the feedback fraction and Vf is called as feedback voltage. The actual input of the input to the amplifier consists of the sum of the signal voltage and the feedback voltage. Here I told that the Vs plus beta into V naught. Vs means here the source voltage plus add up with the feedback network, means the input amplifier has the two signals, one is from the source voltage and another from the feedback voltage. When it add up with the source voltage and the feedback voltage, this called as the positive feedback. If it is subtracts with the source voltage, means Vs minus beta into V naught, this means feedback is out of phase, called negative phase. Negative feedback. If it is add up with the signal voltage, means Vs plus beta into V naught, this means the feedback is in phase. In phase means here it has a same signals, means sine waveforms comes in under the circuit, that becomes same as in the input signal. So that's why it gives the same waveforms, means the feedback is in phase, called as positive feedback, and opposite of that one means the input signal is opposite to the output signal, which is comes under by feedback network, means Vs minus beta into V naught. This means the feedback is out of phase. Out of phase means the opposite of the opposite waveforms of the input signals, called as negative feedback. Okay, so these are the two types of feedback. One is positive feedback and another one is the negative feedback. So let us discuss the positive feedback. The positive feedback is gives the same waveforms as in the input signals. So when the input signal and output signals are in phase, means same, the feedback is called as the positive feedback and it is also called as the generative feedback. Here is the diagram. Here the sine waveforms, input signal S is the source and here amplifier, and after that you have output. After that you have the feedback network. After that you have the feedback voltage Vf. So in the input voltage you have sine waveform, and after amplifying the signals it get the output as a opposite sign, and that opposite waveform is fed back through feedback network with 180-degree phase shift. Then it convert as the Vf, means the feedback voltage converts the sine waveforms as it is when as it is same in the it is same as the input signal. So that's why when the output signal and the input signals are in phase or are in same, then that feedback is called as the positive feedback, and it is also called as regenerative feedback. So consider an electron circuit which has a sinusoidal input is applied. So here I am applying input as a sinusoidal waveforms as an input. If the input signal and the feedback signals are in phase, then such feedback is called as a positive feedback. And the input voltage becomes, the input voltage is Vi is equals to, because it add up with the, when it is add up with the source voltage with the feedback voltage, then it is called as positive feedback. That's why here input becomes Vi is equals to Vs plus Vf. Then modified as a Vs, the equation becomes Vs is equals to Vi minus Vf, means input voltage minus feedback voltage. So therefore you get here the input voltage and the source voltage, means the source voltage becomes here the input. Therefore the gain of feedback amplifier with positive feedback is given by the AF is equals to, means the feedback gain is equals to output voltage by the input voltage. Output voltage is V0 divided by Vs. Vs is the source voltage. Source voltage means that nothing but your the input one. That's why it is equals to V0 by the input signal is Vi minus Vf, that is equals to V0 divided by Vi minus beta into V0. So now divide numerator and denominator by Vi. So then that becomes AF is equals to V0 by Vi. So output voltage divided by input voltage becomes the gain, that is capital A. Divided by Vi minus Vi, that becomes 1, minus beta V0 by Vi, that becomes beta into again gain. So here AF is equals to A divided by 1 minus A beta. So this formula is called the gain of the amplifier with the positive feedback, where A into beta is called as feedback factor and the only beta is called as the feedback fraction. Here the modulus of amplifier gain is greater than the gain of the amplifier, thus the feedback increases the input gain. So here the feedback is greater than the gain of the amplifier, then the feedback will be increases. When the feedback will be increases with hence it is called as positive feedback. So this is about the positive feedback. So this next one, the second feedback is the negative feedback. Then advantages of this for positive feedback is increases the voltage gain and it does not want any phase shift. No, that's why no phase shift is provided. Feedback and input signals are in phase. So then only it will gives us the same signal as in the input, as like input of the source voltage. So next discuss about the negative feedback. So negative feedback is totally opposite of the positive feedback. When the input signal and output signals are out of phase, means opposite of the both of opposite with each other, then the feedback is called as negative feedback and also called as degenerative feedback. So here the signals are opposites. Here let us consider the circuit, electronic circuit, which is which have a sinusoidal input is applied. If the input signal and feedback signals are out of phase, how we can find out of phase? Here see, input signal is the sine wave form and it magnifies by amplifier, it gives the output as oppositely as the input one. So then this signal is, means the output signal is fed back through the feedback network and it gives also the opposite compared to the input signal. So that's why the input signal and the feedback signals are out of phase. When it is out of phase, means when it is opposite with each other, then such feedback is called as the negative feedback. and the input voltage becomes Vi is equals to Vs minus Vf. So then we can write Vs is equals to Vi plus Vf, input voltage plus the feedback voltage. Then we can write the gain of the feedback amplifier with the negative feedback is gives us a AF is equals to, means that is a ratio of output by the input becomes here the Vs plus Vs minus Vf. We can write here Vi plus Vf. Using the above two equations, we can write V naught divided by Vi plus Vf, that is equals to V naught divided by Vi plus Vf is the feedback voltage. That feedback voltage can be written as beta into V naught. V naught is the output voltage and beta will be the feedback fraction. So then divide the numerator and denominator by Vi. Then we get AF is equals to V naught divided by Vi becomes output voltage divided by input voltage, you gives the gain of the amplifier divided by Vi by Vi, that becomes 1 plus beta into V naught by Vi. Again output by input will gives the gain of the amplifier. So therefore the equation AF is equals to A by 1 plus A beta is the negative feedback amplifier, gain of the amplifier, where A into beta is called as feedback factor and the beta alone is called as the feedback fraction. Here the modulus of gain of the amplifier, that is AF, is less than the amplifier of the gain, then the feedback will be decreases, means the gain of the amplifier, the gain of the output will be decreases by the feedback. That's why it is called as the feedback decreases the input signals. Hence when it is decreases the input signal gain of the amplifier, hence it is called as the negative feedback. And advantages of the negative feedback is increases the stability and increases the bandwidth and less frequency distortion or less phase distortion. And the only disadvantage is that it reduces the amplifier gain, because it is the feedback amplifier is less than the gain of the amplifier means the feedback gain of the amplifier will be decreases using the negative feedback. So these are all about the feedback network in that positive feedback and the negative feedback. Okay, so next class will be continued in the next video. Thank you.